Hello everyone, basically I have two models showing me blizzard right now. Alright, don't get mad at me. I know many of you watching this are like, no way, no way. Yes, 2 out of 3 models are showing me blizzard for next Tuesday into Wednesday. And then the American model is saying it's going to be a bit too far to the east, but we will still get some snow from it. Each one of these is a possibility. We could be getting a big storm, or it could be a complete mess. You know, it's still 6 days out, so don't get into your head yet that we're going to have a big snowstorm. I mean, it looks like that's a definite possibility, but it still might go out to sea. So just keep that in mind. So we're very far away from the end game with this storm. But I will say that all 3 models, the American, the European, and the Canadian, all show a very big storm. So if it tracks close enough to the coast, it will be pretty big. It will probably be the storm of the winter for some, if it comes close enough. Okay, so here's how it's going to work. So this is the Canadian model. I apologize for the shakiness here. This piece of energy was going to be coming through on Monday, and you're going to have it's just coming along the northern jet stream here. You're going to have an area of low pressure develop on the southern end of this, so you might have to worry about some snow across sections of the Delmarva and the Mid-Atlantic, and maybe into southern New Jersey and southern Pennsylvania, just a little bit. Not too much of a big deal. If you look over here, you see that there's an area of low pressure developing out here over the sea due to this disturbance moving through, this shortwave. Now, take a look behind this. This is going to move out, and then behind this, look what you have. You have a huge area of high pressure here. What does that signify? Well, that signifies Arctic air that's going to be coming in. So this high pressure is going to be moving in. You're going to get a big surge of Arctic air coming in Sunday night through Monday, and it's going to last through midweek. This Arctic air is going to be sticking around. Now, this high pressure is going to be setting up around here in the center part of the area, center part of the country over here. And since it's setting up farther south, what that's going to allow the energy that's coming in to do, here we go. I'm sorry. Since it's setting up over here, what that's going to allow energy coming over here to do is it's going to come all the way down here. It's going to come all the way down south. Okay, your Arctic air is extending all the way down into here. So your energy is going to come all the way down south. It's going to form a storm, and if it comes far enough, you get a big enough dip in the jet stream, it comes negatively tilted, oh I'm sorry, that's negatively tilted, comes up the coast, and bam, you've got a big East Coast snowstorm. That is a possibility number 1. That's what Canadian and European are showing. American model says no, this is going to set up a little bit further north, this won't come down as far south, it'll form a storm a little bit further north, and the dip won't be as great, negative tilt is not as great. It becomes negatively tilted later, and it goes out to sea, and you get brushed by some snow, but not a major snowstorm. That's what the American model is showing. Alright, so we're going to take a look at these subtle differences between the American and the Canadian model. It's really better to see them between these two models now. So this is your piece of energy that's moving off the coast on Monday night. That's associated with this area of low pressure. Man, could you imagine if this came up north and then we got another storm behind that? That would have been 2 storms in a row. But that's not going to happen. This is going to move out. Then behind this, you get the surge of Arctic air. And now, let's go back 1 frame. You have 2 pieces of energy to be watching here. So your Monday piece of energy, that's going to be moving out. But the western part of that is it's falling behind a little bit. This western piece here is going to combine with this big shortwave that's going to be coming southward. Now, again, remember that your high pressure is setting up over here. So this is all going to come south first. It's going to dig south, and that's where it's going to come together and form a storm. So here we go. Watch how this piece of energy comes together with the southern part of that piece of energy. See that? So from that to that. See, it's all coming together. And this is all positively tilted currently, which is good. You want it to be positively tilted at first, because that means it's going to be digging south. The further south this digs, the bigger the dip in the jet stream, and then the sharper the northward turn is, and the bigger the snowstorm. Okay? So you want this to be digging farther south at first. You want that high pressure to be setting up to the south as well, so this way it comes up like that. Now, if you take a look at your American model for the same time period, here you go. Notice how this is a little bit further behind, right? This is farther out in front. And another thing, notice this is a little bit less of a positive tilt, okay? So let's see if we could see that. See that? Look how strong this positive tilt is on the Canadian model. Alright, so let's zoom in a little bit. Okay, so notice how strong this positive tilt on the Canadian model is, and then look at it on the American model. It's not as strong. I'm sorry, I keep messing that up. That's a stronger positive tilt. Weaker positive tilt. Stronger, weaker. So what that tells me is that for the Canadian and the European models, this second trough is going to be digging farther south. And ultimately, that's going to create a stronger negative tilt when it comes down here and forms your storm, because the dip is going to be steeper. So on the American model, the high pressure isn't setting up as far south. So that's a big difference. Now, here we go. We're going to keep going. Next model run. Again, so this second trough is already neutrally tilted here. This is what's going to start forming your storm, this piece here. And then this piece behind it is going to be what steers this up the coast. And the farther south this digs, the sharper the northward turn on this second piece. And the stronger this is, also, this is going to be pushing this up the coast even more so. Alright? So this is what the Canadian model is showing. Again, notice that's positive tilt. This is going to dig further south. This is going to be pushed further south and then back up. Okay, now take a look at the American model for 120. Here we go. Alright, notice how this behind trough is not as far south as it is on the Canadian model. And, you know, notice that the leading trough is also positively tilted. You started to see a negative tilt on the Canadian model. It's not as strong here. This is more of a slight positive tilt on the American model. And this is not digging as far south. This is your leading trough here is what's going to be creating your storm, which you see is over Florida right now on the American model. This doesn't dig as far south, which means this is, when it doesn't dig as far south, there's not as much of a dip in a jet stream, and this moves east for a longer period of time. So you see that? This is already starting to become negatively tilted, and this is going to come further south. So then you go to the next model run. Now, notice another thing. Number one, this is still positive, so this is still coming south, and this is going to push this up the coast. It's going to shove it. This is a really strong, this is really potent trough here. This other trough that I'm circling right now, this leading trough, is your storm right now. This is your storm. So, notice, that's a strong negative tilt. That's really strong negative tilt, and it's further south than on the American model. This, the back trough that is guiding this up the coast, is a lot more potent as well, and it's digging further south. So now let's look at the American model for that. Okay, so notice that this is farther north. It's not as potent, and your leading trough is becoming negatively tilted a bit later. Okay, it's still not as negative as the other one. And what the negative tilt does, for those of you that don't know, when you see a negative tilt in the isobars here, when you see a negatively tilted trough, that means it's going to start to move northeast. So, because this second trough doesn't dig as far south, and because on the American model it's actually a bit farther behind than on the Canadian model, it's a bit farther behind, they start to combine later. What that does is the leading trough doesn't become negatively tilted until later on in the game, and because of that, it tracks east for a longer period of time, and as a result of that, its northward turn starts later, and it misses most of New England. So that's what the American model is showing. Notice this is your storm. Now, again, look at this. This is still a very strong storm. I think that's 992 in the center there. That's already a really strong storm. 992 millibars in the center here. It's really strong. Both models are all models are showing really strong storm. But the thing that is going to make the biggest difference is when these when do these two troughs or pieces of energy come together? How far south does the back trough dig, which would lead this to a sharper turn up the coast? And then, as this is coming up the coast, how far to the east does this high set up? Because if this high is far enough to the east, this could also end up getting shoved out to the east. And what will also play a role in how far south this back trough comes is how far south the high sets up. The further south this sets up, this high pressure here, this Arctic air mass, the further south that sets up, then the further south this second piece of energy is going to come. Okay? So that's another difference. And then the intensity of this is also another difference, because if it has a bigger intensity, it'll add to the strength of this, the first trough, and it would have the strength to push it up the coast rather than out to sea. Okay? So that's my big kibosh of the difference between the American and the Canadian. Now look at the resulting storm here. So look at how far east that is, though. That is way too far to the east to bring us anything, basically. If you get a track like that, that's going to be a complete mess. See, that this is the American model. So it's all the way out here. And no snow over New England. You know? This is the newest run. That is an intense storm. That central pressure has got to be in the lower 980s or into the 970s, which is really strong. If you look at the Canadian model now, here's your storm. So here's that stronger, more potent trough digging further south, pushing this up more sharply. And then see that because it digs further south here, this gets pushed up. And then take a look at this. Look at that. That is the storm right there. Now, look how close that is to the coast. Long Island, I'll give you it, is right there. Where that mouse right now, that's where Long Island is. And look where this low is. It's right there. This is the Canadian model. And then take a look at this. This is your precipitation map. Look at this heavy precipitation. It's right over Long Island. Right over Long Island. All this red and orange is coming into Long Island, and then that's moving northward along with the storm itself. So another thing is on the American model, this high is further east, which means this is getting pushed further east. On the Canadian, this high sets up back further west, allowing this to come up the coast a little bit sharper as well. So that's another big difference. So there's so many variables that you have to take into account when forecasting the storm. Okay? I'm actually going to stop right here. I'm going to do another video. I'm going to talk about the European, and then I'll show you my threat area for the storm, and I'll tell you what I think could happen.